Yes, ma'am. So, good evening, everyone. I'm Amruta, and today is my absolute pleasure to extend a warm welcome to all of our participants on this day 6 of 2-week short term training program on AI and ML coding using generative AI, which is powered by Indian Science Technology and Engineering Facilities MAB. So, this program is being conducted from March 24th to 4th April. We are delighted to have you all on this exciting learning journey. So let's recap yesterday's session. So last session is all about logistic regression. So today we are going to learn more about machine learning facts using generative AI. So before we begin, here are some important guidelines to ensure a smooth and effective session. So while joining, please share your name and affiliation in the live chat. Use a laptop for better learning experience, especially during hands-on activities with our experts. Filling up the feedback form during each session is compulsory. The form link will be shared in a YouTube chat box. So let me take a moment to introduce Academy InnovaWorld. Our Academy InnovaWorld is dedicated to fostering interdisciplinary learning and research through activities, webinars, workshops, and industry collaborations. Our mission is to bridge the gap between theoretical knowledge and a practical implementation, empowering learners to excel in emerging technological domains. I also extend a heartfelt welcome to our esteemed guest for today's session, Dr. Arunava Majumdar. We are grateful for his presence and look forward to his invaluable sights as he takes over today's session. Wishing you all a great learning experience. With that, let us move ahead with today's session. I hope all of you have a productive and enriching learning experience. Over to Arunava, sir. Please, sir.
Good evening, all. Welcome back again for the session of AI and ML learning through generative AI. As we already have learned many things regarding the modeling on linear regression, logistic regression. Also, we have just have done one program of logistic regression and what regression is and what classification is, what is the difference between regression and classification problems. Okay, all of these things we have learned, and how to generate the code, also how to generate different results of regression and classification through generative AI, through ChatGPT or DeepSeek, and also how to generate the code using the ChatGPT or DeepSeek and use that code in the uh, means how to use the code in your platform. Okay, generate the code and use that code in your platform to generate the results. Okay, we have already learned these many things. So today now we are going to deep inside of logistic regression, which is basically we use in classification problems. So classification problem means the outcome variables are having some classes, especially binary class. Okay, that is either 0 or 1, yes or no. This type of output is there. Then we use the logistic regression will be the will be the good prediction. I'm not saying that it is a best prediction. Okay, let us discuss about something about the logistic regression today and what kind of metrics. Okay, in classification problem, what kind of metrics are required here? Okay, what confusion matrix is? All these things we need to know first. Then only we can go for the classification problem. Otherwise, we can't understand. Yes, code can be generated from a dataset, but we can't understand actually that what is happening inside it. So let's start with some basics and some theoretical part of what classification problem is. Is my screen visible? So let's start with first we will start with a data set. Let us suppose I am defining a data set with some independent and a dependent variable. So independent variable, let us suppose x1, x2, x3, and our dependent variable is y. Okay, and let us consider that all the data set it is following some categorical data. Okay, this is also yes, no, yes, yes. This is also no, no, yes, no. This is 0, 0, 1, 1. This is also yes, yes, and so on. Okay, so here this data set, it is having all independent data sets are also having binary classification. Okay, binary class x1, x2, x3, everything. And also this is our dependent variable, also having a binary class yes, 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 no, and like this. Okay, so we need to check that whether our dependent variable is having any class, means any category or not. Okay, you can see it is a category having two categories, yes and no. So binary classification problem it is. So rather than going for regression, we have to go for classification cases here. And since it is classification, we have to use, if we are talking about the purely statistical methods, then logistic regression, not linear regression or nonlinear regression, logistic regression. Okay, now what logistic regression is, already I explained what logistic regression is. Okay, so logistic regression it is, we will use the same thing, means our linear regression, if we have done a linear regression through this data set, then what we are getting? We will be getting a function y equal to how many independent variables are there? There are x1, x2, x3. These three are independent variables. Sorry, independent variables. Okay, so it means that since these are independent variables, y is dependent, so we can get y equal to an intercept, that is a constant part, a plus a1 x1 plus a2 x2 plus a3 x3. But this particular means function, it will give us generally some numeric values, and which is in floating point. Okay, they're 1 point something or 2 point something or something like that. Okay, which never matches with the dependent variables. Okay, so what we can do here, we will whatever the value we will get from this function, these values, that is 1.2 or whatever these values, we will send this value to another function. And this function I already told you, we the function, it converts this value to the probability. Probability means in between 0 and 1, we know that the value of the probability, basically, not basically, value of the probability is always in between 0 and 1. Okay, so since the value is always in between 0 and 1, so we need to use a function. Okay, just wait. Yeah, sorry for the interruption. Is my screen visible? Okay. Yes, what you are going to say? Yes, we need to means yes, these values. So whatever the values we are getting in this function, linear functions. Okay, this linear function value, it giving us a any type of floating point value point wise, which actually doesn't match with the dependent variables any category. 0 1 category, it never matches. Okay, so these value, whatever the value we will be getting, let us suppose the value is 1.5 we are getting. Okay, now this value, to convert this value to any 0 1 form, we need to pass this value to a function which is called a logistic function, which is 1 minus, sorry, 1 by 1 plus e raised to the power minus z or minus x or whatever. It is better to write it. Convert this one z. Okay. So this value we need to parcelize this 1.5. We need to put this value here. Okay, that is it becomes 1 plus e raised to the power minus 1.5. Okay, this will convert it to any value in between 0 and 1. Okay, 0 and 1. And we know that any value in between 0 and 1, it actually defines a probability. Okay, now how to, but this probability value, it should be near equal to now 1 by 1 plus e raised to the power minus 1.5. Okay, whatever the value is, let us suppose the value is 0. Let us suppose the value is 0.32. Suppose it may not be equal. Okay, so 0.32, but 0.32 also doesn't match with this binary classification, that is 0 and 1. Okay, so what can we do here? We can do one thing. If our value, whatever the value we are getting, is less than 0.5, okay, then we will put into the category as 0. And if our value is greater than equal to 0.5, then we will put into the category 1. Okay, so 0.32, we will, it is converted to the value 0. And if the value is more than 0.5 or equal to 0.5, let us suppose 0.6, it will be converted to 1. Okay, so we will create a function like this. So after using these values, means after converting the value to the probability form, now we will pass this form, we will use another function which converts to 0 and 1 like this binary classification. Okay, by this category 0 point less than 0.5 or greater than 0.5. Okay, so that this function, now that is a function definition, it is like this. That is fx equal to 0 if x is greater less than 0.5 and 1 if x greater than equal to 0.5. So we use this function to convert all these probabilities to 0 and 1 category. Okay, now let we our predicted values will be like this: x1, x2, x3, and this is the original value y, and this is y predicted. Okay, let's suppose it is 2 1 0 0. This I'm not this is our data set, main data set. Okay, now our predicted, these are our original values, these are our original values, original. Okay, let us suppose our predicted values are, so for 2 1 0, let us suppose our predicted value is 0. 1 0 1, the original value is 0, our predicted value is 0. 3 1 1 1, our predicted value is, let us suppose 0 0, and this is suppose 1. Okay, let us suppose this is our, after the prediction, after applying the logistic regression. Okay, if we pass these values 2 1 0, okay, to the logistic regression function, let us suppose we are getting 0 and which matches with the original value of y. Again, if we pass 1 0 1 value to the logistic Yes, yes, you're audible. Is it okay now? Yeah, yes.
Good evening, everyone. Am I audible to everyone? So, kindly just drop a message in the chat box, please. So, requesting due to some technical issues, we are requesting everyone to join in this group as soon as possible. Requesting all the participants to join in the group which has been shared in the chat box. Requesting all participants to join in this WhatsApp group, please. So kindly join as soon as possible so we can start the session from where we stop. Requesting all the participants kindly join the group as soon as possible, and requesting all to join using the official name so that we can identify it. Requesting all to join using their name, official name, so that we can identify you. So you can continue. I will take care of the rest of the thing. Yes, sir.
Okay, thank you. So, yes, thanks. So, what we was discussing. So, the predicted value. So, what I was discussing that these are our original values, and after using the logistic regression, these are our predicted values. Okay. Now we need to check that how our original values and our predicted values will match. So, first one is confusion matrix. confusion matrix, it basically true negative, false positive, and false negative values. Okay, so let me first, I'm not going to define everything. Okay, so let me first giving you a little bit of idea means what all of these things are is actually. Just wait. These are the true positive and true negative definitions. So what true positive means? Well, suppose I am going to give you a matrix here. Only this matrix has the cells true, false, true, false. Sorry. Okay. Now what true positive is? So the number of instances where the model correctly predicts the positive class. Positive class means suppose these are the original and this is predicted. So this is predicted true, predicted false, original true, original false. Okay. Now true positive means if positive class. So positive class means I'm talking about the true values. Positive class means generally true values. Okay. Now predicted is also true. Positive is all original is also true. So if both are matches, this is also true and this is also true. So we will say this is true positive or TP. Okay. Now, false positive. What false positive is? The number of instances where the model incorrectly predicts the positive class, where it should be negative. Okay, so it means that incorrectly predict the positive class where it should be negative. So true, false positive, it means that the class is positive, but our predicted value is negative. This one. So, this. Okay. So actually it is false, but we predicted is okay. So negative. Sorry, positive. This is actually wrong. Okay. So now another thing is false, false. So false, false. This one is also correct values. This one is also correct values. This is incorrect values. These are incorrect values. This matrix is called confusion matrix. Okay. Now, why this matrix is, let us suppose, how can you predict that your model accuracy is good or not? Okay. If you have predicted the true values truly, you have predicted the false values falsely. Okay. So let us suppose original true, predicted value is always, original true is here. Original, this is original true, original true. Okay. And the predicted correctly, this one. Original true, and you predicted also this is true. This is one. So you can write here one values are there, which is means predicted correctly. One and one. So how many one values? Okay, true is one and false. You can see, okay, your predicted value is false. So how many of these values are there? So one and false, this is one. So original true, you have predicted false, this is one. Original one, you have predicted one, means true, true. How many times? One. Okay. Now Your original 0, predicted 0. How many times? 1. Original 0, predicted 0. How many times? 2. Original 0, predicted 0. How many times? 3. So 0, 0, false, false 3 times. But true, false. Original false, but predicted value is true. No false values is there. So it is 0. So you have to check that